We're doing exercise 8.8 and this is question 2. 8.8 denotes chapter 8 differentiation of year 1 Edexcel derivatives. Okay, our question is we have a diagram that shows the curve. This is our curve with the equation y is equal to 1 minus x squared. Point A has coordinates 0.6, 0.8. It lies on the curve. And I have point B, C, and D with x coordinates 0.7, 0.8, and 0.9. Verify that point A lies on the curve. Okay. We have if I want to verify that point A lies on the curve, I have the equation of the curve that is, I'm doing the A part. I have equation of curve, which is nothing but y is equal to root of 1 minus x square. The x coordinate of point A is 0.6. So I will substitute 0.6 in the equation of the curve. So I'm going to get my y coordinate as, I'm putting it directly on the calculator. You need to write and then put. It would be 1 minus 0.6 the whole square. So my y is equal to 0.8. Okay. Now since my y is 0.8, so point A. So what is my point A? My point A, that is 0.6 comma 0.8. This is my 0.8 if you could clearly see. And this is my 0.6 that you can again clearly see. So point A, that is my 0.6, 0.8, it lies on the curve. Now let's look at the B part. Second part says that use a ruler to estimate the gradient of the curve at point A. If I want to estimate the gradient of the curve at point A, okay, you know that the gradient of any curve is the slope of the tangent to the curve at that point. Okay, so if I want to find the gradient of the curve at point A, the gradient of this curve will be equal to the slope or the gradient of the tangent to the curve at that point, that is A. So to find the gradient of the curve at A, I need to place a ruler and draw a tangent line at A so that it touches my point A. So I have drawn a tangent line over here so that it touches the point A. At my point A is where it is at 0.6 and 0.8. That is what we have derived. Our point A is at 0.6, 0.8. After I draw the tangent line, I need to estimate the slope of the line. That means I need 2 points on the lines where I can use the formula of the slope. The formula of the slope, that is m is equal to y2 minus y1 over x2 minus x1. Okay, I need to estimate 2 points. So any 2 points which can be clearly visible to you, you can take to find the gradient of the tangent at point A. So here I have drawn a tangent. So I have taken my first point where my x coordinate is 0.5 and my y coordinate is 0.9. Okay, I can clearly see this point. Whatever point you can clearly see, you can take. And I have taken my second point over here. when my x coordinate is 0.7 and the y coordinate is also 0.7. Now I want to estimate the gradient of the curve. So the gradient of this curve would be gradient of the tangent at point A. Since I wanted to estimate the gradient of the curve at point A, I will find the gradient of the tangent at point A, which is nothing but y2 minus y1 over x2 minus x1. My x1 my x1 is 0.5 and my y1 is 0.9 and my x2 is 0.7 and y2 is 0.7. So this is going to be y2 minus y1 over x2 minus x1. So this is going to be nothing but minus 0.2 over 0.2. So this is nothing but 1. So my gradient of the tangent at point A is nothing but it is 1. So I got the gradient of my tangent or my gradient of the curve at point A. Gradient of the tangent at point A is equal to the gradient of the curve at point A. Now my C part is telling me find the gradient of the line segments AD, AC, AB. Now I know point A is 0.6, 0.8. I need to have the x and y coordinates of point B, C, and D. So they've asked me to find the gradient of the line segments. First, I will find the gradients of the points. Okay. Now, I know the x coordinates of my points B, C, and D. I need to find the y coordinates. X coordinate of point B is 0.7, point C is 0.8, and the x coordinate of point D is 0.9. I need to find the y coordinates. A's coordinates I already know 0.6, 0.8. B, x coordinate is 0.7, and for the y coordinate, I would substitute the value of x in the equation of the curve. So it is going to become 1 minus, it is going to become 1 minus 0.7 the whole square. So the y coordinate is going to be 0.7 comma 0.714. Similarly, it is going to be over here. X coordinate of point C is 0.8 and y coordinate is going to be 0.6. Okay, x coordinate is 0.8, that is known to us. For point C, x coordinate is 0.9 and the y coordinate, I'm going to substitute the value of x in this. So it is going to be 0.435. I want to find the gradients of the line segments. I know if I want to find the gradient of the line segment, the formula for the gradient is nothing but y2 minus y1 over x2 minus x1. Now I will use the formula of my gradient y2 minus y1 x2 minus x1 and I want to find gradient. So first I'm going to find gradient of AD. So my gradient will be, I'm using A and D. So y2 minus y1, so it is 0.435 minus 0.8 over x2 minus x1. So the x2 is 0.9 minus 0.6. Putting this on the calculator. So it is 0.5 minus 0.8 over 0.9 minus 0.6. So it is going to give me minus 1.22 approximately. Okay. Now gradient of AC. Y2 minus Y1. Y2 minus Y1. So it is 0.6 minus 0.8. X2 minus X1. 0.8 minus 0.6. Please note for A, I'm going to, this is my X1, Y1, and this will remain the same for all the gradients. So the gradient of AC is nothing but it is minus 1. Third one, third part, gradient of AB. Y2 minus Y1, so Y2 is 0.714 minus Y1 is 0.8. X2, AB 0.7 minus 0.6. So it is going to be 0. And over here it is 0.7. So the gradient of AB is minus 0.86. Now our last part, I want to comment on the relationship between B and C. My gradient of the curve at point A was minus 1. Okay, and my point A is 0.6 comma 0.8. I have to find gradient of AB, AC, AD. So I want to comment on the relationship between B and C. You see AD 0.6, AB 0.7, 0.8, 0.9. So this is going away and away from A. So as point D, C and D, they are going away and away from A. Okay. So if you see over here, they're going away from A. 0.6, 0.8.